Assalamualaikum and hi. So today we're gonna learn learning outcome 3.5 resistor in series and parallel. So today I'm gonna teach you resistors in series. So in the figure below we have the arrangement circuit resistor in series. We have voltage R1, R2, R3 we each arrange beside to each other. As we know, it same the arrangement of capacitors in series, but the difference is it have the same current, which is I total equal to I1 equal to I2 equal to I3. But the difference is which is the total voltage is shared by the resistor, which is V total equal to V1 plus V2 plus V3. So we get the V total is different. So from that we also can calculate the current and resistor, which is IR effective equal to IR1 IR2 plus IR3 from the formula V equal to IR. So from that we can connect in series, we can get effective resistance which is R total equal to R1 plus R2 plus R3. So we get the total of effective resistor or the total resistor. So we have to remember that value of effective resistor is always greater than any individual resistance, because the effective resistance is equal to the value of summation of the total number of resistance that we have calculated. So you always remember that value of effective resistance is always greater than any individual resistance. So this is the short notes that you can jot down in your notebook or anything that you can remember it.
Today I want to share some notes of resistors in parallel. There are some characteristics of resistors in parallel, which is voltage free, same across each. Total current I splits into three separate parts, which is I1, I2 and I3. This is the formula of the resistors in parallel, and this is the example diagram and of how to explain the formula of the resistors in parallel. They have some various type of parallel resistor, and this pie diagram is show that the type of parallel resistor and they have some example of resistor parallel, and this is the diagram of the example of resistor of parallel. The question is asked of want to find out the total resistance of this circuit, and it shows that the circuit is connected with parallel, so we must use the formula of the resistor of parallel, which is 1 over total resistance equal to 1 over R1 plus 1 over R2 plus 1 over R3. The final answer of this question is the total resistance equal to 85.67 ohms.
Effective charge is a term in use in electric circuits analysis to define the resistance between 2 points in an electric network.
For series circuit, the effective resistance of three resistors R1, R2 and R3 is shown as R equal to R1 plus R2 plus R3. For parallel circuit, the effective resistance R of three resistors R1, R2 and R3 is shown as 1 over R equal to 1 over R1 plus 1 over R2 plus 1 over R3. When the resistors are in series, the current through each resistor is the same, but the resistor value and the voltage value is not same to each other. When the resistors are in parallel, the voltage drop across each resistor is the same, but the resistance value and the current value is not same to each other. Thus, effective resistance for resistor in series is equal to V total over current, because the current is constant. So V total is equal to V1 plus V2 plus V3, or we can change it to the equation effective resistance is equal to R1 plus R2 plus R3. Next, effective resistance for resistor in parallel is equal to V over current total, which is the voltage is constant while the current is the total of I1 plus I2 plus I3. So we can conclude that the effective resistance in parallel circuit is equal to 1 over R plus equal to 1 over R1 plus 1 over R2 plus 1 over R3.
Now I want to explain the tutorial question of chapter 3 question 8. This is the figure of the question 8, and figure 3.3 shows 3 resistors connected with battery of EMF 12 volts and negligible internal resistance. The first question is calculate the total resistance in the circuit, and the second question is calculate the voltage across the 8.0 ohms resistor. The answer of the first question is like this. The resistance of 5.0 ohms and resistance of 8.0 ohms is connected in a parallel, so we must use the formula of the circuit connected in a parallel, which is 1 over Rx equal to 1 over R 5.0 ohms plus 1 over R 8.0 ohms, and we found that Rx is equal to 80 over 13 ohms. This and the Rx and the resistance of 6.0 ohms is connected in a series. So if we want to find the total resistance, we must use the value of Rx and R 6.0 ohms and plus together. So the final answer of total resistance is equal to 8.08 ohms. The second question is want to find the voltage across the 8.0 ohms. Since we know that the value of total resistance is 9.08 ohms, and the value of EMF is equal to 12. So we use the formula of V equal to IR to find the total current, which is 1.322 ampere. When the total current is equal to 1.322 ampere and the resistance is equal to 8.0 ohms, we also use the formula of V equal to IR to find the voltage. So the voltage is 7.932 volts. So we want to find the voltage across the 8.0 ohms. We must use the total voltage to minus the voltage of 7.932 volts. So the voltage across the 8.0 ohms is 4.068 volts. The second question is, the figure 3.4 shows that 3 resistors of resistance 2.8, 2.0 ohms, 6.0 ohms, 2.0 ohms, 4.0 ohms, and 6.0 ohms are connected to a battery. The current from the battery is 3.0 ampere. Calculate the values of the currents I1 and I2 if they have negligible internal resistance of the battery. So this is the answer of this question. Firstly, we must find the total resistance of this circuit. First step is the R of 6.0 ohms and R of 4.0 ohms is connected in a parallel, so we use the formula of the circuit is connected in a parallel. So find the value of Rx is equal to 12 over 5 ohms, and the Rx and R of 2.0 ohms is connected in a series. So we use the formula of the circuit connected in a series, which is R total equal to Rx plus R 2.0 ohms. So the total voltage that calculated out is 4.4 ohms. We must find the voltage, we must find the current, so we must find out the voltage first. The circuit of R 6.0 ohms and R 4.0 ohms is connected in a parallel, so the voltage is same. The voltage of R 6.0 ohms is equal to the R 4.0 ohms. So we must use the total voltage to find out the so we use the total voltage minus 2.0 ohm voltage, so we get the values of voltage of 6.0 ohms and 4.0 ohms, which is 7.2 volt. So we use this voltage divided by each of the resistance, which is 6.0 ohms and 4.0 ohms, to find out the I1 and I2. So the answer of I1 is 1.8 ampere and I2 equal to 1.2 ampere.